Okay, so light, we need to learn about all these things. Okay, this is part of the syllabus. We learn about reflection. So regular reflection, diffuse reflection, all these have been covered last week. We also talk about characteristics of image formed by a plane mirror. Okay, and then the effects and uses of reflecting surfaces. Okay, there are some application questions that can actually come out for your exam papers, even maybe in school, your project, your worksheet. Okay, somebody mentioned growing plants as one of the project in school now. So we need to go into refraction here. So effects and consequences. Then we will discuss a little bit on the dispersion of white light. Of course, investigate, effects of reflection and refraction in practical activities. You could be doing your practical in school and expected to draw the light rays accordingly. Now, we have learned all these last week, so I'm just going to quickly run through the slides. So we know light travels in straight lines, yeah, and then sources of light will be those that give out the light. We also talk about speed of light. Later on, I'm going to share with you the speed of light in vacuum, in air, in water, and in other medium. Okay, so speed of light is faster than the speed of sound because we actually see flashes of lightning before we hear the thunder. So most of the time, the moment you see the lightning, what do? What's the next action you will actually take?
Cover your ears, airstrike incoming.
Yeah, correct. I'll do this immediately. Okay. When I'm alone, I will do this. If let's say my child or my daughter or my son is in front of me, beside me, or even my cat, I will cover their ears instead. Yeah. So this is what we'll do. Okay. Are normal human being just like me. So we will tend to, cover our ears so we don't get shocked by that thunder. Okay, so when light meets any surface, reflection of light occurs. But sometimes certain surfaces, right, allows light to pass through. Then when the light passes through, refraction occurs, which is what we are learning today. So let's quickly run through, okay, how the light rays enter our eyes. Remember incident ray and then reflected ray? Do you still recall there's the angle that is being formed, from the ray as compared to which particular line? You still remember that line that we talked about? What is that line? If you recall, quickly type into the chat. Let me see whether you are correct. Yes, Nikki. There's this particular line that you need to draw, right? Correct or not? Okay, it's at that position where you see the light ray touching the surface. Yes, it's called the normal. Usually we draw the normal as a dotted line. If you recall, I also did teach you how to draw all the rays, the normal, and then the angle. Still recall or not this part? So incident ray is the ray that comes in. Okay, once it hits the surface, it will be reflected. All right. Assuming that this is the type of surface where light cannot enter. Okay, light can't pass through. So it's going to be reflected only. Now, the angle of incidence and the angle of reflection must be the same. This is the rule of reflection. Okay, certain rules that you all have to always remember. Okay, and then this line here in dotted lines, right, is actually drawn at right angle, okay, to the surface that it is hitting, the light is hitting. We call this the normal. Yes, Nikki?
The angle on the left of I and the right of R, they are not the same, right? They are both different. Like the angle on the left of I and right of R.
You mean here?
This one and that one, yes, they're both different or the same.
They are the same, because if this is right angle, right, the normal is right angle to the surface, okay? So like this right angle. So here also right angle, isn't it?
Makes sense.
Right? So it will be 90 degrees. So you take 90 minus away 48, what do you have?
19 minus 48, I think it's 32 or 42.
Yes, 42. Okay, so this is 42 degrees. This must be 42 degrees also. Y'all know this, right?
Yes.
Yeah, mathematics lesson now. Okay, so we talk about the diffuse reflection as well. Now, every single light ray still obey the rule of reflection. Okay, when they hit the surface, when the light rays hit the surface, it's going to be reflected, and the angle of incidence will be equal to the angle of reflection. Okay, so for every one of them, it will be obeying the law. Okay, now, so because they are being scattered in many different directions due to the uneven surface, okay, we get diffused image, which is also known as diffuse reflection. All right, at the end of it. Okay, so we also talk about the images here. Now, we love this one, right? Okay, and then compared to the sea water, look at this, because this is like the waves due to the strong wind, okay, causing the surface to be, very disrupted. Therefore, no proper image is being formed. So we also talk about the characteristics of image formed on a mirror. Must know this, okay? Okay, number one, upright. What's the meaning of upright? What's the meaning of upright? When I say that, oh, I look into the mirror, the image is upright. My image is upright. Okay? What's the meaning of upright? The opposite of upright is what? Sometimes it's easier to talk about the opposite. If I look at my image and I don't see upright, that means I am upside down. Correct? Upside down, right? Inverted. So if this is an upright image, okay, head is still where the head level is. The image and the object is the same. The object. Okay, my image head, right, will be the same as mine. Okay, and then we talk about the same size as the object. You don't look at yourself and suddenly you see a very fat you or a very skinny you, right? Unless your mirror is not a plain mirror. Laterally inverted, good. Yep, so left appears right, right appears left. Then it's the same distance behind the mirror as the object is in front. And then it's virtual, it's not a real image, okay? It's a virtual image. Now, so we talk about the different kinds of mirrors as well. Remember, convex and concave. What is the meaning of convex? Someone tell me. When I say that this is a convex mirror, what do you think it is really like?
Curved outwards.
Curved outward, so it's like bulging, right? Like has got a big stomach kind of thing. Okay, so it's bulging out, rounded. Yep. So if you are talking about the concave mirror,
Then they'll be curved inwards.
inwards. Very good. So we can use a spoon as an example. I remember Tammy was the one who showed me the spoon last lesson, right? She's like shaking in front of me, there, like that. It's true. Okay, so when you look at the images of these two mirrors, right? Look at yourself in these mirrors. You remember we saw the video as well, isn't it? So I have the links given here for you to actually watch the video again if you wish to. I sent you all the notes, right? I did, right? Last week. So you can review all these again.
Wait,
Now,
there's
if
one
you
more thing.
wish, sorry?
Convex mirrors aren't usually made out of glass. They're made out of a thin layer of reflective plastic.
It can be. It can be. I have seen the real mirror also, but it is very unstable. I know what you mean, because if it's like curved, right? Okay, it's very difficult to have something made of glass. Yeah, very easily broken. Jensen, it is used in cats to see to the left, to the right, one at the top. Okay, used in cats. What's the meaning of cats? Cars. Okay, I was thinking, how come I never realized that about my cats? I'm almost going to grab my cat already, and try to look at her. Anyway, okay, so concave mirror, we know the usage, right? We even have this table. Then last week, I saw some of you trying to take picture, right? Then I told you, no need. I will be sending you the notes. And I did send it to you. You need to read all this, try to remember, but don't just memorize without understanding. You need to know what each term represents, okay? You need to also know, like the concave mirror. Next time you go to the dentist, right? Or you look at your mother's mirrors, you know, they call it what? The beautician mirror or something like that, you know, it will actually enlarge. Okay, so your mom can see the eyebrow clearly, eyelashes clearly, etc., right? So yes, go and borrow the mirror, look at it, and you can understand how it works. So we stop here last lesson, and today we continue. This part here is pretty interesting, and I think many of us experience this all the time. Okay, do y'all go swimming? Y'all go swimming, right? So when you go swimming, and let's say you drop your goggles. It happened, right? Okay, you drop your goggles into the pool. When you look at the goggles from where you are standing, you're not in the water, okay? Your upper body is outside the water. You look at the goggles. Does it appear like it's very, very near to you? It's actually very shallow. It looks like it, isn't it? But the actual fact is, okay, if you just try to reach out to that certain distance, you can't grab your goggles, you know. You are actually supposed to go deeper down. So that is the thing that those very good fishermen will do. You know, some fishermen actually they use their sphere, right? Okay, to throw into the water. Then they aim the fish not at where the image is, they aim it lower, and they are very smart. They always manage to get the fish. Okay, so why is that so? Because refraction has occurred. You have to understand when you have light moving from water into air, the light rays still travel in straight lines, but it will change in its speed. So when it changes in its speed, it is going to move away from the normal in this case, okay? When you have, let's say, a stick in water, or maybe even your glass of water, you put a straw in, do you see that the straw is not straight? It looks like it is being folded, okay, or tilted to a certain angle. Yeah, so this is known as refraction. Okay, not reflection, but refraction. Okay, know the difference between the two. All right, so you need to understand, okay, behavior of light. When a ray of light moves from one medium means the material it is moving through. So this so-called material, it can be air, it can be glass, it can be water, it can be many different substances. Yes, Tammy, works with glass as well. So later on, I will be showing you about medium can mean solvent. So in science, you see one term can be used to represent quite a number of things. Okay, so later on, I'll show you the speed of light, okay, in different medium, in different material. Right. When light travels from air into glass, two things generally happen, okay? So when this light ray moves from air and enters the glass, okay, it can, and hits the glass, I should say hits the glass, two things can happen. Okay, number one is it gets reflected. Remember I talked about light entering the medium, entering the surface. The surface allows light to pass through. Just now I mentioned this, right? So other than just reflection, the light ray can also go through the glass, okay, because it's transparent. But can you see that it's not moving in a straight line? By right, you would expect, you know, the light ray will travel in a straight line, isn't it? But it didn't. Instead, okay, it actually moved towards the normal. Or where's my ruler? Hold on. Yeah, my ruler is here. So let's see. I need to draw the normal. So this is the normal. Okay. This is the angle of incidence and the angle of reflection, right? So the light ray actually goes through the glass and is moving closer to the normal. Okay.